Frank Barkow studied architecture at Montana State University and the Harvard GSD. In 1993, Frank and Regine Leibinger founded their practice in Berlin. Their interdisciplinary, discursive attitude allows their work to expand and respond to advancing knowledge and technology. Current research projects have focused on digital laser cutting, infra-light concrete, facade systems, space frames, and ceramic elements. Current projects in Berlin include a new master plan for bear sharing pharma and a high-rise near the main train station for Libico development. Frank has recently taught at the EPFL in Lausanne, the Harvard GSD, and the University of Wisconsin-Milwaukee, in conjunction with his firm winning the Marcus Prize for Architecture in 2007. Barkow Leibinger's research work has included the 11th Architecture Biennale in Venice, and was also shown in the Architectural Association in London, in conjunction with the publication of the Catalogue, an Atlas of Fabrication. Their work is in the permanent collections of MoMA, the Heinz Architecture Center in Pittsburgh, and the Deutsches Architecture Museum in Frankfurt. Digital Kraftwerk refers to Barkow Leibinger's commitment to investigating emerging technologies and harnessing them for ongoing building projects. Both digital fabrication, analog fabrication techniques are applied to the tooling of materials comprising structures, cladding, facades, and surface making in their architecture. Building case studies such as the Trutech Building in Korea and Gatehouse and Canteen in Stuttgart show examples of the research applied to finished buildings. And for those of you who are trying to get AA credits, there's some forms in the back, continuing ed credits, so be sure to fill one out before you leave. So with that, I'd like to introduce Frank.
I'm coming from Portland. I did a talk at lunchtime, so this is a little bit similar to what we were talking about earlier today. And I'm also coming from Los Angeles, where we did a workshop at USC with the students where we were producing facade mock-ups at a scale of 1:1. So with this, and working with our sustainability engineer from Stuttgart, Thomas Auer. So I think this idea of fabrication, issues in sustainability, and technology, emerging technology, and how we're using it in our work has been an important topic in terms of how we've been working. So in a way, the lecture tonight is really structured. The sort of front end of the lecture is really about a lot of the research we do in the practice in terms of looking at materials, looking at tools, how we work with them. One of the things we've been doing the last 5 or 10 years in the practice is this idea of working academically. Both my partner Regina and I have been teaching in Europe as well as the States. The research component, which is in the practice, which is usually students working with us, developing ideas, developing projects, and then the practice itself, where we try to bring in the research work into the building projects so they're informed directly by that. So one of the things, the way we're working is, and this diagram kind of illustrates this idea of looking at tools, looking at new tools, both analog, digital tools, and looking at how tools might affect materials, whether that's raw materials or pre-manufactured materials, and how that might inform or lead to an architectural conclusion. So one of the things that was happening when we came out of Harvard GSD in the late 80s, early 90s was software was really very much about using it to make form, that somewhere down the line then would be an idea about how that would be materialized, and then what tools would lead to that. So in more recent years, we flipped that equation where we'll begin with a specific material, look at tools for transforming a material, and then relocating software in a position like that, and then seeing how that might formalize or lead to a spatial result. one of the places we started working in the late 90s was for the Trump machine tool in Stuttgart. Trump is the leading machine tool company in the world. Their idea was to use lasers and specifically for cutting and shaping sheet metal. So while we were master planning for this company and building individual buildings, some of these I'll talk about a little bit later, we began to look at their technology and how we might apply that to producing architecture. So in this case, this is a 5-axial laser cutting head. It's cutting a gas tank from an Audi. So we were wondering, you know, are these machines that we could start to use in terms of producing both initially kind of architectural components and in later years more substantial cladding systems, structural systems, things like that. So this idea in this image of this Eames splint here was a kind of project that we always like, and we show this often in lectures. You'll probably know from your history, it was the Eames splint. It was developed during the 40s, during the war years, out of the relatively new technology of plywood. Plywood could be formed to produce the splint. But in a way, this piece set up the rest of their entire project in terms of producing furniture systems for the 50s and 60s. So this we liked very much. Again, I think the way we work in the office is, we're working with students, but it's, I would say, relatively flat hierarchically, where students will come into the practice, will bring software skills, scripting skills, parametric issues. We're looking at ornament, geometry. And again, as a kind of evolving practice, we're constantly looking at technology, looking how we use it. So in that sense, we're very much open-ended in terms of how these might work or be used within our practice. One idea that we start doing also with students is this idea of active archiving. So what active archiving was for us was, rather than relying on, say, building catalogs for our work, we started producing our own architectural building systems. A couple of years ago, we had a show at the Architectural Association in London called Atlas of Fabrication. It was a catalog for the show, and at the same time, it was an exhibition showing some of these techniques, some of these components that we started to produce. So the catalog itself is a very simple document, basically stapled together, where we could add some of our systems into it. And at the same time, let me take this off. We could add to the system or take systems out of this if we needed to, as they're replaced by other or new technologies. So this is something that we continue to work with. But as a kind of document, it was terrific. We made this catalog. It cost about $10. We could produce this in a couple of weeks. So in your own work, you might think about this in terms of, in a way, collecting work and then in a kind of open-ended catalog form. So this is the exhibition in London, where you see models at different scales, working pieces we're working on, as a kind of demonstration of not any one particular project, but really just showing systems that had to do mostly with materials and their tooling. That show later traveled to Berlin to the 32C gallery there, where we put them in these cabinets by Konstantin Gritschik in almost like a natural science museum way, where we catalog these elements and then put them in the cabinet. So some of these are pieces of building projects that we're undergoing. Some of them were simple research projects, but starting to show, in a way, the content of our workshop or the content of the practice in an exhibition format. So, and I'll go through some of these examples fairly quickly, but another question was, in looking at these tools, we would send, in these examples, students down to Stuttgart, where they would look at a particular machine, understand what that machine could do in terms of a kind of action on a material, in this case, cutting, stacking. The first machines are fairly fundamental, where they're doing two-dimensional laser cutting of sheet metal. With these machines, in a sense, we would study these, see what the capacities were, how fast they could cut, the economics of using these tools, and then to apply these to a system. So, and these first examples are relatively simple moire screen systems. We began to apply digital scripting to these surfaces, where there's this idea of a system that can be repetitive, at the same time have a certain amount of variation in it. So at this point, the scripting is fairly naive. It's simply producing almost what I would call kind of ornamental pattern making that we could start to think about in terms of architecture. Another thing we work on in the European scene, I guess, is architectural competitions. We're constantly doing architectural competitions. At the same time, win, lose, or draw, we like very much the idea of having particular research projects as part of the architectural competition. So in this case, we had an empty site over here in Dresden. As you remember from your history, Dresden was this beautiful Baroque city that was largely destroyed during the Second World War. It was a city, built of a very beautiful sandstone. So the idea was to, in a way, reconstitute a historical form in the site of this Gewandhaus near the center of the city, but tectonically to think of it very differently in terms of how it would be built, the physical walls of the project. So the exercise was, we basically looked at all the proposals for that site from the last 200 years, which are these guys on the left, and then sort of composed those into, on the right, which is this kind of composite form, which became the proposal for the scheme. I mean, something we also like is like, in a sense, an idea for generating an architecture on the site that's not something we simply drop into a site, but has to do with the history of a place like that. But looked at the surface profiles of the Baroque walls in Dresden, and in the lower left began to look at these templates that could be a stacked wall surface. So the first studies were of these, kind of Baroque but relatively abstract walls that could be made almost like a series of louvers of digitally cut stone or concrete that would stack to form these kinds of walls that then later could constitute the construction for the building itself. So the building itself, again, is sort of both familiar and unfamiliar. Familiar as a historical form in this historical city. At the same time, it can appear completely opaque or completely transparent through this kind of louver system of wall making, using our research to inform the making of this project for a competition proposal. Another area, and this has been around for a long time, is bending. Bending is an old technique for shaping metal. Like many of these other things, it's now a digital process where, again, these are MIT students going down. They had discovered with a limited sheet of metal about this big, they could get a certain amount of folds. Those pieces then can nest into larger arrays or matrices of surfaces. Again, completely independent from any particular use or client or utility or even economy for using these, but just trying to understand how we could use this machine to produce a surface like this. This piece then later became part of a research project, part of another competition in Zurich for the Kunsthaus, which is the addition to their modern art museum, where we were really interested in kind of revisiting the space frame as a kind of structural idea for facade making. Now, space frames have been around, since the 50s and 60s. Now, digitally, a space frame could be something that could vary, it could change in relationship to structure or daylighting criteria. So, in a way, again, this was the research project within the competition project and started to produce these in our workshops, digitally cutting these, and then assembling, and then bring structural engineers in very quickly to start measuring these systems to see how they might apply. Ultimately, this was a proposal for a curtain wall at the museum entrance, where you have this kind of interstitial space at the entrance, which has its own climate, which is different than the galleries, which are stacked to the right in terms of humidity and temperature and all these things, as a kind of wrapper and envelope around the entire space, which ultimately in the final version became concrete precast perforated surface that wrapped around the entire building. And other studies, and some of these were started also with students, were, for example, the discovery of meter and a half rolled sheet metal that by simply looping the material and fastening it by welding or riveting, we could produce a kind of architectural pavilion. So in this case, by making more dense coils, you can get a much stiffer structural roof. It can get larger and drop out as these kind of structural columns. We even combined it with a kind of curtain wall of plexiglass, which follows that. But again, looking at a particular material, then looking at a technique for, in a way, organizing or collecting that material, that for us had a kind of logical process in terms of leading to a system that could be both structural as well as having an idea for lighting a kind of pavilion space. Again, really, completely independent in this case from any particular site or program, developed as a kind of prototype. Another example, here we're working with a Swiss structural engineer, Jörg Konset, and Jörg's idea was to use structural depth. In this case, this is a large box beam that can bridge from left to right with this kind of squiggle walls, which are a webbing. These would be cast in a digitally shaped concrete formwork, and the height of that box beam, which is about 3 or 4 meters, then could be used as loft spaces or office spaces that could be, again, a structural idea, but of a kind of dimension that you could use as an architectural project. At the same time, and again working with students, we like to look also at historical precedents. This is a famous example of Thomas Jefferson's serpentine walls at the University of Virginia, where he has this very thin wall, like a single brick thick, and by having this curved footprint of it, you have this very strong self-stabilizing structure. So we think, looking forward at new technology, but it's often interesting to gauge these things against historical examples. In something like revolving laser cutting, this is relatively new technology. I really like it because it's all of a sudden now you have a three-dimensional piece, off-the-shelf piece, these tubes which can be rotated and then fed through a machine and cut. The first pieces were these, highly intricate work pieces. We could cut multiple pieces from one tube section and just ran these to see how precise we could make them, how quickly we could cut these things. Again, independent from any particular use for them. Another area that we're working is this idea of the architectural exhibition. And we like architectural exhibitions a lot because they're sort of in between the research work and the building projects we're doing. And what's kind of nice about exhibitions is we're not really like I suppose a lot of our contemporaries not really working in shows that are about showing drawings and models so much, representation, but more really about using them for kind of architectural installations, so that they are forms of architecture in their own right. With those institutions we started working with, had begun with Trump at the top as a fabrication partner, and In the meantime, we keep collecting new partners, new workshops basically, that have specs that work specific materials in specific ways. It's an evolving sort of collection that we keep adding to for working these projects. A lot of these are around where we're based. We're in Berlin, which is, I think, marked at the top. Between Berlin and Zurich, we have about, I don't know, 12 or 14 of these workshops that we work on continually, depending on what the project might be. So, for example, the last thing with the tube cutting ended up, that's a piece we produced on the lower right, is a kind of array that we produced for show in Basel, Switzerland, looking at the topic of technology and ornament. So ornament wasn't something that we just woke up one day and decided to focus on, but was enabled in a way by these machines. What used to be very difficult, very labor intensive to make, with these machines is quite easy to do. So in this case, we were drawing two-dimensionally, a kind of array of densities for these tubes, which then were translated digitally and then ran through these print machines. So this piece, which is kind of a sculptural piece, there was an idea of rotating these tubes in this kind of array. Again, thinking about a kind of application which ultimately became this. We ended up putting the tubes in a project for a showroom in Sweden, where by rotating the tubes you could do a number of things. You have this kind of visual effect, kind of moire effect. We started looking at it in terms of exterior sunscreening, which is what we do in Europe a lot. We could look at the kind of transparency or opacity looking into the interiors of the showrooms. So in a way, for us, that was a sort of logical series of steps in terms of looking at a tool, a material, and how that might lead to a more inclusive architecture. By this time, this is a project we did in Berlin for an installation where now we're looking at scripting in a much more precise geometrical way here. In this case, Shu, a student of ours, looked at a script where each cut would produce two pieces which would then fit into a kind of topographical, tangential, I guess, connective series of surfaces that would produce this piece. So in this iteration of the thing, it's a chandelier. It's this kind of sculptural piece. It's a prototype. We're sort of working out how the lighting would actually work. But this, in the meantime, has become a piece that we built for the Deutsche Bank. So it's kind of moved from prototype to an actual produced architectural piece. And this is this sort of mad version of the thing as a proposal for the Contemplating the Void exhibition at the Guggenheim Museum in New York. So this thing is a gigantic chandelier in the void of the Frank Lloyd Wright building in New York. Wishful thinking. In this piece, this is another piece that we produced for the Venice Biennale that was mentioned a little bit earlier. In this case, the pieces fit into a wood platform, a kind of CNC cut matrix. The piece began as a highly organized geometrical system that people could move and rearrange in a kind of interactive way. But it was looking at this system as almost, I suppose, almost like a game board where these pieces could be moved and rearranged. So it began as this very highly formal structured thing, and then at the end of the exhibition, it was kind of like a gigantic bad hair day or something. But another example, I'm going through these kind of quickly, but Stuttgart, this was a competition we won in Stuttgart across from the Weissenhof Siedlung for a commercial building for wholesale fashion designers. But we won the competition, and then within a few days we could start producing this idea for a fin wall, cutting in these sections on the left. Those pieces in the section on the right are then attached to a very cheap precast concrete frame. Then we started producing these in our courtyard, our studios, out of core 10. So we cut 3 pieces from each tube. These would go up 22 meters. But bring the client, to our studios, show him these things, tell him where they could be cut, how much they would cost, how long it would take to make them and deliver them to the site. So in a very precise way, for a system that is essentially unprecedented, show how that we could use this and apply this to an architectural competition that, in this case, we actually won. The prototype as a experiment, I think, comes back. This is one of our student projects from the AA in the late 90s. This idea of a search for an architectural prototype that comes from a technical system. And I guess this is kind of a fancy way of simply saying that for us, design follows technology as we discover it and find ways to use that. Again, a lot of this has to do, like in some of the earlier examples, with the engineers that we were working with. These are a lot of English and German engineers that we work with. Also, and I think to say up front, we'll usually start a design process with our engineers at the initiation of a project rather than something that happens further down the road. A couple years ago, we were asked to do a pavilion for the German Architecture Museum, a temporary pavilion in their garden space. We teamed with Werner Sobeck, a very talented structural engineer in Stuttgart. We discovered by scroll cutting these tubes, you could have very complex radiuses. He said, if you want to make a kind of arch out of these things, it's really a terrible idea because these are like limp noodles, basically, and don't do anything. But he was recommending that we could do digital sort of bending to produce these forms with a simple bending machine that's sort of digitally guided. So with our students, we started looking at different proposals that use a specific size tube that can be radiused in a certain shape that could produce these pieces where each arch could be a unique piece in the array. And I think, the other thing, so we ended up settling on this one, which the curator picked because of its flexibility and the kinds of exhibitions they could have in it for 6 months. But it's also, I think, the pavilion, and we've done several pavilions with students, is an interesting type as an experimental typology. It's fairly open-ended programmatically. They're usually temporary, but we looked at a number of these in terms of more architectural and experimental building typology. So in this case, we had a kind of primary and secondary structure that would hold us together. With Sobeck's office, we started to look at a shingle for this. Using scripting, I think we limited this to about 12 different shingle types. They clad over this arch. So even though the recession came, we ran out of funding, the Deutsche Bank pulled out of this, but we were still able to build the pavilion inside the Architectural Museum and show it, in this case, as a one-to-one mock-up. So here you see these macrolon, which is a kind of synthetic plastic shingle. They overlap so that in the summertime the pavilion is ventilated. We could silk screen on these surfaces to give more sun screening, and we could also embed photovoltaic cells in this to generate energy for the pavilion for the 6 months. Then we looked at even building this thing, even in the course of the weeks that we put this thing up in the pavilion, we were improving details. Like this is a simple wire connection to the arch, which we then attached a Velcro connection. So you could take these shingles and just sort of pop them up and onto the frame in a very, very quick fashion. Another example of a pavilion is this so-called Sorak platform. This was a project for Stavanger, Norway, for an artist by the name of Cecil Tolless. Cecil's, all of her art ideas revolve around the sense of smell. So she wanted a series of pavilions that could be constructed and added onto in the course of the next 5 years for exhibitions for her work as well as other artists. In this case, we looked at the Norwegian wood industry, which is a really fantastic material. We use it. It's a really very good sustainable material. It's easy to work. In this case, the sort of core cell piece is a series of wood ribs. These ribs can be added with secondary pieces. We could make entrances into these spaces. We could use the structure and then clad it. In this case, this is an ETFE. These are sort of these membranes of a kind of chambered plastic membrane that wrap around these things in terms of insulating and also conditioning the light that comes into these. The rib system we were able to use for displaying some of the artifacts, some of the pieces that Cecil was bringing into it, as well as daylighting the spaces, and then finding a way where we could, as a series of modules, every year, we could add a new cluster to this thing until it's all essentially built out in 5 years. So again, looking at the pavilion as a type, in this case, to look at wood construction and how that might contribute to building that. The second half of the lecture I wanted to talk about was our work at a kind of building scale. This idea of a research practice. This soundbite from Icon magazine from a couple of years ago was the idea and the kind of desire from our point that the work we do, and the work we do is really sort of everyday office buildings, factories, cultural buildings, but the idea that the technology that we're using is something that we can use in everyday kind of construction situation. That means economically as well as practically on these kinds of projects. So if this is the way we've been working in terms of research as related to, say, things like exhibitions, to buildings, ultimately it's our building projects that are conclusive in terms of discovering ways for using this kind of technological research. So in this example for smart materials houses, we wanted to look at how we could use kind of material research for the production of low-income housing for an IBA project outside of Hamburg. You might remember the IBA project's in Germany. It's the International Building Exhibition. This is an idea that's gone back 80, 90 years. It was an idea of looking at progressive ideas for housing, for areas that were neglected or low income, for looking for new ideas. So there were two components to this competition. One was smart price, and ours was to look at ideas for smart materials to produce basically a block of flats. I think we have 6 flats, loft spaces in this building in Williamsburg, which is an industrial suburb of Hamburg proper. We knew about a history of working in precast concrete. This is Khrushchev over here inspecting a model in 1956. If you've been to Eastern Germany or Eastern Europe, these kinds of housing blocks sort of are, all over. They're pretty terrible, actually. They're all over the entire landscape of the area. But what was interesting about these things is they did have these kind of types. So you could produce facade systems, or you could produce these ornamental screen walls at the end. But these things all collected to produce housing in the 50s, 60s, 70s throughout Eastern Europe. What we wanted to do, in a sense of revisiting this project, was to look at infralight concrete. Infralight concrete is a super lightweight concrete. It's insulated with a recycled glass, so it's about 1/3 the weight of regular concrete. And importantly, it's a self-insulating material. So this is the concrete on the left. Then the other idea was to couple that with glue laminated timber for the floor decking as a kind of tension material. So this kind of CO2 chart was a way that helped us construct an argument for which materials we wanted to use. So if you look at the concrete we use, and if you can't read German, you can see that it's about the third of the CO2 between regular poured in place or precast concrete, and then with this sort of minus CO2 use of the wood in combination were a pretty attractive couple of material. The other idea about the apartment building that we liked was the fact that it could be constructed really quickly. You could bring the pieces on site, almost like a house of cards, and within a couple of weeks have the entire system constructed. We liked also, and working with our energy engineers, that if you're going to work with concrete, it might as well be expressive. It's a very plastic material. It can be shaped in a very sculptural way. So because of our earlier fabrication work, we knew we could make form work that in this sense kind of a scallop surface. You could produce a form. And because the material is homogeneous, there's no finishes on it. It's not a sandwich system. You can make one type by pouring like this. By flipping it on its head, you can have a different type. You have different types by pouring the concrete higher and lower. And that would produce this component, this concrete piece, which is very much this kind of multitasking element. It's pure infralight concrete. The finish can be the inside or the outside. We put a series of conduit in it, which has hot water or cold water flowing through it. So that's the heating and cooling system for it. We formed it so it was a self-supporting element that could be stacked on each other. We didn't have any of these sort of German cold bridge problems with the insulation of it. And then in our shop started to build these models in 1:20. In this case, we took rigid foam, and you can cut them with a hot wire, and then combined it with these plywood sheets. So in a way, the model duplicates exactly how we would construct these in reality by simply stacking these pieces up. And because of this aspect of it being self-insulating, the facades can move and shift over as long as structurally they align with each other and the loads come down. We could do a very dynamic facade in relationship to the floor plates to generate exterior spaces along the perimeter. Again, these are these kind of little pocket terraces on the outside. In this case, we combined it with wood triple glazed glass windows with an extra sheet in the exterior to make the building acoustically quiet. It's very close to a very loud highway. And then to produce these kinds of interiors. So you have a core, which is wood, also on the interior. The units can be organized as open loft spaces, or they can be divided into more conventional sleeping living rooms, kitchens, and could sell for a very low price to the people who live in this community. It was an idea that we went crazy with, and we tried an even crazier version of it in this version. In the last year, we discovered that you can build in probably in Holland and definitely in Austria now high rises up to 20 stories in wood construction. So we thought this would be an amazing idea if you coupled the wood construction with the infralight concrete as a kind of stacked system. The idea being that these blocks, you could just sort of bust them off and bring them down to the site and then begin to stack them and then connect them into these wood sections. Because the material, again, the thicker it is, the better the insulation quality is. At the same time, we're really interested in the idea of how it might affect the daylight coming into this deep building section as we're showing here. Another idea that we looked at for an infill project in Berlin was another structural idea, also working in wood construction of a kind of canillary idea where these are work-live units where the box cells work as a catenary structure, which is this kind of chain idea. So the slipping has to do with that structural friction between those. What was cool about this project is by bridging that space, you would get essentially a completely column-free space underneath that, which could be used as a workspace. So we can develop something like this and then look at it as a kind of development project for a kind of empty site in Berlin with two party walls on the left and right. And this is a kind of insertion project into something like this. So in this diagram, this is showing the structural, this sort of bridge hanging idea of the kind of residential bits sandwiched in between the open working spaces. So again, a kind of structural idea, material idea leading to a prototype that could easily fit into, and also by code, definition of code, and exiting into a site for Berlin. The last few projects are construction projects. Trutech Building was a piece we did in Seoul in Korea. We'd never worked in Asia before. We've been used to doing these competitions in Europe. The context we knew very little of. It was in this one of these last development sites in Seoul called the DMC at the north part of the city. Seoul, as you probably know, is this very heterogeneous city of high density, low density. It has this pretty dynamic landscape that's rolling through it. This amazing sort of crazy graphic image of the street by day or night. They're a 24-hour city. And what happened is we inherited this site within this kind of master plan that to us was generic. Not much of this had been constructed. For us, it was difficult to how we might work into a site that for us had very little context. We were fascinated as students by buildings like this in Boston. This is the Harry Cobb and I.M. Pei's Hancock Building, which you might remember in the early 70s, this idea of a mirrored glass surface. In the lower right, it was contextual in the sense that it would reflect something like Richardson's Trinity Church. But what was sort of interesting about that surface, it was this attempt to make the thing perfectly flush. It never was. It was always a little bit of distortion. So we began to think about a facade that would make a virtue of that. So these are one-to-one mock-ups that we're building in our courtyards, at our studios, and discovered with very little, with a very shallow depth, you could achieve an enormous amount of, almost like a kaleidoscope, distortion in that surface as a way to relate to this kind of emerging context of this master plan we were working. The building itself is fairly straightforward. It's a shell and core building. This is the facade wrapping around a steel construction. Part of it's underground. The core is off center and pushed to the corner. The facade is almost like a lace. It wraps around the building and it continues above to create a roof garden in this site. So this is the building where, again, you see the city being literally constructed from right to left. These are building sites that are now been filled. But the building would, in a sense, mediate between the buildings, which are these kind of, not too bad modern buildings around it, between this, very, very public exterior and a very, private interior for offices for German tech companies and showrooms at the lower level. In order to produce this facade, which again is really the kind of architectural emphasis of this project, we looked at different patterns for glasses, limits of glass sizes, started with a facade grid, added diagonals. We started looking at 3D elements, sort of faceted elements versus 2D elements in terms of balancing the economics of this and the buildability of it. By taking one facade type, we could flip it on its head to produce another one, and then by combining that, with two-dimensional flat facade elements create this really, really complicated facade. The building itself is at the showroom entrance level, diagonal to this park to the upper left. And again, the core is kind of pushed off to the end, the back, where there's very little light. So in the building section, you see that facade is, again, operating at a very flat depth of about 20 centimeters. And then this bigger indentation at the bottom is where the entrance to the building is. We were trying to figure out this geometry. At some point, it just got crazy, so we just went to the shops and started building this out of plywood. So on the left is just a model about this big, so we ourselves could understand better how those connections would actually work. The interiors work kind of like they're open loft-like spaces, so the interiors are these sort of, again, like a lattice screen to the interior. Each individual piece had its own kind of kit of parts in terms of glass sizes. All the glass was cut by Viacom in Minneapolis. It was then shipped to Korea. The Koreans then were building the frames for the windows there close to the building site itself. So what you see is a conventional off-the-shelf aluminum window profile that had a little extra material at the bottom of it that could be cut with a German CNC machine to produce these complex connections. So on the lower left are the profiles as shown from their building catalogs. On the right side are the Koreans cutting this with a CNC machine. They bought the machine in Germany, taught themselves how to use this, and then coupled the profiles with these joint stiffeners, which kind of controlled the geometry, and then began to fabricate these pieces close to the site. So it was kind of it was a great process in the sense that the Koreans had no idea how to do this. But they were totally ambitious to learn how to do this and to produce a building like this. Because that we needed help, this is our engineer, Jerry, came over from Hong Kong and ran workshops with these guys to produce these pieces. So a corner piece in the lower right, very complex piece, but at the same time, in a very low-tech way, these guys are kitting the silicone joints by hand to produce each piece. Again, unlike some of the research work before, we needed to prove to see the system was sound in terms of waterproofing, in terms of wind and rain. Blasted this in this kind of provisional wind tunnel here. It worked. The client gave approval for the project, and then we were able to go in production. So these are the pieces being staged on site and then being lifted into place and then bolted into the concrete frames of the building in a kind of very, very quick sort of process of building. From the interior, the exterior, it's a low E reflective glass. From the interior, it's either a clear view out through these or through a kind of shadow box profile, which is this translucent pieces in the more complex geometry of the piece. Again, at the end of the day, we weren't really so interested in the pieces themselves, but really as a kind of architectural tectonic, but really how the facade would change over the course of the day in terms of reflectivity, transparency, opacity, how it would change by day, by nighttime, how it would even be affected by buildings that we had no control of. Local building across of it has LED advertising, which also somehow becomes captured and part of our facade system. In the film here, you can see the facade responds to people walking by weather, traffic, even by these insane window washer guys. They're dangling from this thing. So in a way, it was really about the whole phenomenon, how that facade would behave and change over the course of seasons or 24-hour cycle, all that stuff. So it was really less concerned about the physical materiality about this thing, but actually the visual effect of the building. Other engineering components, one was these huge barn doors we produced on the upper levels to bring machines in to the display rooms. The entrance was also a special piece that we engineered and fabricated and dropped in, as well as the entrance stair, which is this triangle shaped piece in the plan. Working with Schleich, our structural engineer, really liked the idea that the stair could be almost like a marionette, suspended by these steel cables from the roof of the double height lobby. So here you see that actually constructed the stair itself is a ribbon of welded steel, which makes it stiff, and then it's simply attached to these steel cables with a wood version on the interior of our exterior facade that we did in glass. So we finished this thing in 2007. 6 months later, a boutique in downtown Seoul copied our facade perfectly. They even improved it, I think, in terms of its construction. Both, I mean, completely horrifying us and I think flattering us at the same time. But you have to be quick on your feet there. These last two projects, which happened at the same time, I'm going back to the factory, which I showed you in the beginning in Stuttgart. A factory is constantly being added onto, adding new lands, adding new acquisitions. In this case, what used to be the back of the factory became the front entrance. We developed a gatehouse project here, which was, for this company, was fantastic because finally we had a building type which we could really pull all of their technology into in terms of developing a building project. In engineering this also with Werner Sobeck, we had this gatehouse project, which is very simple programmatically. It's a kind of information point. It's a control point for visitors, for the employees who work with this. And Sobeck said, well, let's see what happens if we just take the columns off the end of this thing and just let the thing cantilever out 20 meters. So, okay, great, sounds good. Let's try it. So this is the last column here. There's 4 columns, 2 here in that row and 2 back here, and then this thing goes flying out over that. In order to do that, or one of the ways we started thinking about this was these guys were producing these at Trump, these decks that were laser cut, laser welded. They can be used for tabletops. They can also be used for things like ship decking. They're pretty light and extremely strong. So one of our ideas was, well, can we just scale this up to produce a dynamic roof like this? So this is an early quarter-inch model that we produced with the roof hovering out over this thing. The roof's about 60 centimeters, so it's that thick. At the same time, from Werner's office, we started inheriting these kinds of vector plots that he was showing us to show where the loading is. So where it's blue is where the compression of the roof is, and then in the back, you see these kind of ghosted endpoints. Those are the columns where the roof is in tension. So, I mean, we always love these kinds of images, and we were curious about making this stuff legible in the process. So we started in a kind of a dumb, naive way to produce roof patterns as a kind of truss that would register that logic through a series of coffer elements in this truss roof that would change. So in the final version, and this is the model also being laser cut, similar to how we built it in real life, it's extremely light at the end of the cantilever and then becomes more dense at the connection points to the columns. At the same time, we were looking at ways of integrating lighting into the system so it could work on a 24-hour lighting cycle, building mock-ups in our studios and looking how, say, the light might work, and then going back to the old one-to-one mock-up. In this case, to show all the systems that would be in it, laser-cut pieces, mechanically fastened pieces. We had an integrated gutter into the system here. The webbing here is also something that varies in terms of its location in the roof, which is this. I mean, the roof is crossing this plan where, again, you have these column points here, 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 and here. Very simple interior core, information, service, toilets, and then a curtain wall, kind of double curtain wall wrapping around that. So in the sections you see the roof cantilevering out over here, and then this kind of mega foundation in the back here for simply keeping the thing from tipping over. In building it, I mean, this idea of everything being digitally fabricated and produced was a bit of a fantasy. This is an example of an expansion joint where we just use simple old-fashioned welding to put the pieces together. In putting the thing on site, we built these strips off-site in the factory, then shipped them on these huge trucks at 3 o'clock in the morning, and then put them on these kinds of these kind of ribs that hold them in place. The columns are also up there, clad in a protective plywood. Then we kind of ganged these things together, bolted them together, put these, you can see in the background, you see these gurneys that you're lifting it in place. So in this sequence, you're seeing the roof being slowly lifted onto these columns. Like 1,000 employees from the company come out to see this thing happening. You're at this point where you're really testing the difference between theory and reality. You'll get a chance. We dropped this thing in place, and then the roof kind of bounced a meter up and down, and then slowly lifts into place. And then we knew we were in pretty good shape. We were still surprised at how dynamic this roof. The roof is like a big ski that kind of goes backwards. It cambers this way, and it cambers this way. And then, as was intended with the structural engineering of this, by putting these sandbags on it, you kind of post-load the thing, which then brings it into this perfectly flat surface that still had a little bit of adjustability. So again, we were surprised at how dynamic the roof was in terms of having to fine-tune that, which then produced this kind of effect in the project and lighting. The other sort of project in this larger project was the curtain wall. Some of these screens, which work as a moire when they open and close. But we looked at a history of German garden wall, making where it was simple, just almost like firewood stacked between these vertical pickets. And then with these branches, we started to produce, I suppose, a kind of digitally drawn version of that. But then this guy really wanted to kill us. We drew this thing, and then he had to glue each one of these things together with a capillary glue, and then lifted these in place by his crew to make these screen walls, which are, of course, ornamental, but also provided sunscreening for the space. It's a double facade, essentially, in 40 centimeters, where you have double glass on the outside and a single layer of glass on the interior that produced an entirely glass curtain wall. So the tubes are plexiglass, the glass, it's sandwiched between glass, and then the vertical posts, which are here, are laminated plexiglass. So the whole piece is either transparent or translucent. In order to do this, we developed a joint, a gasket joint at the top. This is the roof, which is dynamic in the sense that it can bounce around, and then a kind of accordion gasket at the top that allows that to move when there's snow on it or something like this, independent from this curtain wall that wraps around the interior in order to produce the building. It acts like a kind of lantern at night as an entrance thing. In this last project, and this occurred at the same time, the campus restaurant, also engineering with Sorak, was this building here. It was a different kind of building type on this industrial campus in the sense that it's not meant to be added onto as the factories in the back. You can see where they're being and have been added to. It's kind of the social center of this campus. It's a cantina, which is kind of a cafeteria that works in 3 shifts, but it's also an event space for them. They have musical events there. They have parties there, lectures there, and the entire campus is connected underground through a series of tunnels. So that was also an important way of looking at that. We knew the roof was also in this project going to be a significant element, the organizational element for the building. So again, with student interns looking at structural hierarchical system, leaf structures, and began to look at a series of study models. In this case, always thinking about a specific material. So this one would be about precast concrete. These kind of spiral ones were about steel construction, and the honeycomb one was about wood construction. So what we ended up doing is developing a hybrid system, kind of primary structure of steel because it's really strong. We get really big spans, and then infilling that with this cell system of glue laminated wood. So right away with these study models, thinking about the roof as a fifth facade, as they would say in Germany, as a filter for conditioning the daylight into these spaces. So this was an early sketch model. At the same time with the sound bite in the upper left was the idea of finding a fabricator at this stage of the process that could help us realize a project like this. Again, going back to the exhibition, we were doing mock-ups at 1 to 3. In this case, at the Norse Forum in Oslo. This is an architectural exhibition space. We mocked up our roof here. These are projects, other projects from colleagues of ours, Alex DeRoque's Naked House and Helen Hart's recycling projects from the North Sea, to see what that would be like. And then produced with our fabricator in the Black Forest, Holzbau Alman, produced a performative mock-up at 1 to 1, looking at glue lam connections where we knew that each joint could be unique because of digital production and fabrication. Certain details we'd simply dumb down, like the steel connections are simply bolted through. They were pretty simple. This is Gunther down at Holzbau Alman. He draws with his right hand and left hand at the same time. He's, and essentially redrew our entire project, every screw, every connection, and then put that into their hardware and software in terms of producing these production runs. So these are the tools they have. They were doing the production run. So you see our pieces over on the left. They could cut these, produce these, and then truck these things out to site and put them up, in a sense, just in time. In the bay next to our production run, they were running one for Chateaubriand at the same time for his Pompidou project. So these guys were really the key to realizing this process. So here you see the pieces being brought on site, being put up. The steel's already in place. They're lifting these things up and then holding them up with these sort of helper columns until the top skin's put on, and this works as a structural system. The building itself, like I said, is earlier that the campus is crisscrossed by a series of tunnels at this -4 level. So the building sits in this kind of excavation, almost like an amphitheater, as a kind of landscape. So in the site section from the left, from the Autobahn, there's a berm. The site rolls across. So here the mezzanine level is actually at the ground level, and then the primary double height space of the building is at a lower level. So it's very much a kind of introverted or controlled space. The sequencing of the steel's up, and in a few days we could, sort of infill the triangles between the steel by putting these cells in, and then skylights and decking that is really very much just hovering roof over this amphitheater excavated space. And then in terms of the scale of it, the roof is quite thick, sometimes up to, say, 2 meters. So you either have the single height space at the mezzanine or a double height space in the main eating hall here. The plans are fairly simple. This is the tunnel connection, the entrance by winter, and then a summertime entrance over here, kitchens back here, service stuff over here. And then by sinking the space into the ground, the client gained this mezzanine space here, which they used right away. We produced these column clusters to stiffen the roof laterally, and then combine that also with a core, elevator core up here. Another thing that happened with this honeycomb idea or the cell idea was to, in a sense, program each one of these, working with our energy consultants. They were either skylights, depending on daylighting position, or artificial lights, or acoustical panels, sometimes both, that informed, in a way, kind of gave a functional use to each one of those cells in the structure. So this is a kind of view in the double height dining space, which again is flexible enough to be used for different kinds of events in the course of the year. We combined that also with a series of precast concrete stairs, which in a kind of landscape way allow the lower level to connect almost as kind of continuous flow up to the mezzanine space behind it. So you have either this very high space, or you have a very compressed space here at the mezzanine, where the thickness of the roof is almost the same dimension of the clear height in that area before. So you really experience this in a very physical and direct way. Another sort of project within this was ceramic tile. In Germany, there's several companies that still produce terracotta ceramic tile. In the history of this country, in the early 20th century, many civic buildings were covered in terracotta ornamentally. Of course, Louis Sullivan used this also in places like Chicago. So we were, very excited about the idea of producing a custom tile for this building that was in line with the kind of geometrical ideas about the building that we could apply to it. So in this case, this is an exterior tile in a very dark cobalt blue, either as a concave piece or a convex one that fits together, or interior tiles with a custom color that are simply mortared and placed onto the wall. So in the exterior application, it works as a kind of rain screen skin that attaches to a series of frames with the entire building, again, wrapping around the base through it. So the building has this kind of interior. It also has exterior spaces, these kind of porches, which it can use in warm weather out to the south. I just had a couple more images, if you have time, of the example of one of our recent academic studios. This was for the Gina studio, and this question was how can we use an outsized technology, in this case for BMW. This is a studio we ran at the Harvard GSD. In this case, we were working with Chris Bangle, who's the head of BMW design. And Chris had an idea for a car that came out about 2 years ago, which was called Gina. You can see it on YouTube. There's like 6 million hits for this thing. But the idea was a kinetic skin, a kind of elastic fabric, like a Lycra skin, for a car that could change when you opened it, changed it on the interior. Chris's idea was sustainable in the sense it's a very lightweight material. You could skin the car in 2 hours. The internal sort of space frame of the car does all the structural requirements. It works as an exterior skin idea. It works as an interior. And we thought this would be a really great idea for housing concepts. So we ran this as a suburban housing studio at Harvard. In this case, these are tent-like structures that can change by moving the connection points at the ground. It could work as a vertical system, as in Megan's project here, where these each flat can open up to the weather, or it can close in this kind of expanded metal like skin, or in Nacho's project, a kind of space frame with an elastic skin that can move. You can add to your flat, you can reduce it, you can orient the building to the weather, to the sun, or move it, you can change it. It was thought in detail in terms of a kind of elastic Gore-Tex system. But these were the kinds of projects that resulted, again, from looking at a specific technology and asking how we might use it, which I think is the key to some of the things we've been doing in these studios. So I'll finish with this last image. Again, thanks for the invitation, and it was great to be here. Yeah, sure. Yeah.
One-to-one prototyping and mock-ups are really important to the way your firm develops ideas and projects. Mm-hmm. I'm wondering, when your firm was young, how you were able to sort of incorporate that into the projects, or when you started doing that.
Well, when we started doing that, I mean, we were always doing the building projects as a kind of test, but I think what's happening, we start doing these at the beginning of a process now. So I think we're doing this in a more concentrated way in the last 5-10 years, probably. So there's always this kind of idea of one-to-one prototyping in relationship to a building project. You saw 3 or 4 of those today, but I think we also producing them independent from specific buildings. But I think to answer your question, it's really become a focus in the last 5-10 years. Mm-hmm.
You worked with Trump, the laser cutting facility.
Yeah.
Was that seems like a really symbiotic relationship that you had with them, where they had this technology that you learned from and you then used it to build their buildings? Was that an intentional thing, or was that something that just you luckily stumbled upon and was very generative?
No, it was super intentional, but it took a while to get to it, because their applications were for the automobile industry. They weren't really that interested in architecture, so they needed to build quickly. So they themselves were not that interested. It really took a while to get to it. And the earlier projects used their technologies as a way, as what we call sort of accessorizing the projects. Maybe it was a handrail or a guardrail inset, to the point where we really wanted it to be driving major structural areas, cladding systems, everything. So, but it took a while it took a number of years to get to that. And then once we knew that, we could start to apply it to other projects, other clients. But these companies, they produce tools, but they're not themselves aware always of the application. So we started using their machines. Architects like Herzog de Meuron started to use them for projects like the Barcelona Forum for punching metal. So in that sense, it's the application is not prescriptive. They, once you get into their workshops and start looking at possibilities, that the limits are quite amazing and quite unlimited. But it took a while to get that on board for them.
Environmental engineers, and you talked a lot about how you get them on board early on. How much is it them offering input into design ideas and altering your intentional vision, or is it you trying to really go with something and they respond to it?
Well, it really depends, like you're an engineer, right? Structural engineer, right? I mean, it really depends. The Swiss guy, I mean, we knew that was his project. One of his interests was this idea of a kind of, programming structural space. So we kind of went to him for that. Other engineers like Sorak, I think, will usually come to him with a series of ideas, and he's a kind of enabler. But there is definitely, also kind of challenging, a back and forth. The cantilever roof was something that he was really keen on developing. So I think that there's a kind of dialogue that's happening, but it's definitely at the beginning. So it really depends on the individual, and we definitely shop around for engineers who we know will offer certain specific expertise or way of thinking. But it's very different than, say, in the beginning, where you kind of bring the structural engineer at the end of the process, and they kind of prop your buildings up, and thanks, and they take off. It's a much different kind of dynamic, I think, and an exciting one, considering that we used as students. I remember in Montana, structural engineering was really about making formulas and doing this, to thinking about it as really an instrument that we could really use to drive a lot of our architectural ideas. Yeah.
Could you expand on you had a quote up there about the store critique. Could you expand on that and why that was the kind of preface to the point that you were making there?
Oh yeah, it was a little tongue-in-cheek, I guess. The magazine put that in there. That I guess we had in the schools, a lot of our friends and colleagues were working at, I guess what we call the boutique scale, the smaller scale stuff. And when we started working with more digital fabrication, I guess we were interested in it not being exclusive, being high-end, but how could you use that technology for what we saw as like the Korea project, a kind of everyday office building. Can you use this not at a kind of boutique scale, something that's super high budget and very precious, but something that's letting the technology trickle down to kind of everyday, what we see as everyday building projects. So that's where we kind of wanted to position ourselves. So that's, it's a little tongue-in-cheek, right? But,
So then, as a follow-up, you didn't discuss the budget of these projects, or did they all follow that they, for the most part, you work with fairly limited budgets, or that they?
yeah, it depends. The Korean project, it's a different building culture. So that building in Korea was fairly affordable. That project in downtown Berlin would be unaffordable. So, it really depends on what you're working at. So the economics of these things definitely vary, and not all of them are the lowest budget projects you could imagine, but it really depends where you're working. The difference between, say, working in Switzerland and working in Korea is enormous in terms of costs and complexity and also know-how. So that's something that's constantly varying from project to project. But again, as these technologies, it does seem that the more we do this, that as these workshops become more accustomed to doing these things, the prices start to slip down. So again, wood construction to us is quite attractive. It's not, the material itself is not that expensive, and structurally engineered timber can do, imagine in a region like this, you have the same opportunities, but we can do a lot with it.
As you're putting these projects together, you talked about the local construction culture and whatnot. Do you find that to be a limiting factor at all in terms of finding a contractor that's able to assemble and sort of perform?
Well, yeah, it's an interesting question, because despite this whole thing about globalization and everything being the same, it's really not. So when you're working in different building cultures, I think our thing is always to get on the ground and see what's possible. That usually means working with local architects or engineers and trying to understand what the possibilities are, what the limits are, and then in the best sense, how do you exploit those areas of building, and how does that inform the architecture that you make? So again, the building we did in Korea would be, we would never do a building like that in, say, Switzerland again, never could. So it's always for us interesting to understand what the resources are, what the limits are, but also, again, also the opportunities, and how to exploit those in the best sense of the word in terms of making architecture. But I think that for this, it's also interesting because it brings a kind of differentiation in our work. We're not interested in doing, that project simply, I guess what you almost say, a kind of signature architecture of simply reproducing the same approach wherever you go, but actually to use those conditions on the ground to directly shape and inform the kind of architecture that we make. Yeah, no, it's really a good question, because at some point there's this kind of risk management going away. It's like what can you get away with and when, and what point do you get into real trouble? So I think that you know, we had these Koreans who would do it. They had no experience with this. In order to make that a safer process, we brought in Arabs from Hong Kong, so to support that team. So that prototype that was wind tested, that was crucial. Had that thing failed, you know, we would have gone to a much more conventional facade system. So that has to happen way up front, you know, without affecting, you know, building schedules and all these things in a negative way. But yeah, it's really a lot about risk management too with a lot of these things. Yeah.
Small, beautiful little models that then get sort of blown up to this terrific scale. And I'm curious if you are working at all in fabricating maybe your own interior pieces that are sort of fitting into a much more medium scale, that maybe these things are getting pervasive on the inside as well. And
Yeah.
integrate with them.
Yeah, we just did like a penthouse for ourselves, like an apartment, and it's more the mini to medium scale, and in that case we were casting precast, you know, with students, like the idea of ornamental texture being generating more surface for heating and cooling, but that was happening at much more, you know, like I think you're talking about interiors scale. So you know, right now we're working for Deutsche Bank and it's all interiors. All of a sudden we have this interiors department. But I mean, I think we like the idea of scaling up or down. So we might be working on something at the scale of an interior. I didn't show it tonight, but we're also working at the scale of master planning in Berlin. So I think that sort of calibration between scales is really interesting, and what that means. I think there was one example where we saw something that was the scale of the table, and we thought we'd make that the scale of a roof, and it's not so easy. It's not a one-to-one translation. Something has to happen by doing that. But that's super exciting, I think, the idea of looking at multiple scales through different projects. Mm-hmm.
If you're doing methods that you've been exploring, do you come to a project before knowing all the intricacies, wanting to try out a certain method, or is the method coming from the projects? Well, because
Yeah.
I guess some of these seem complex enough that it would be difficult to do all that research while you're also trying to accomplish the rest of the project.
Yeah, that's a good point, because sometimes you just don't have the time, you know. So sometimes the research stuff has to happen. It needs to be protected from the, you know, cycles of construction and limits of that. So some of that stuff happens in the side as pure research, but what happens is we try to find a limited number of research projects in each project. So the cantina was about a wood structure and about the tile making, and those research topics arose during the process of designing that project. They didn't come from outside or from somewhere else. They actually arose through that particular project, and again, the kind of opportunities and limitations of a project like that. So some of the stuff is autonomous and, you know, waiting to go into production for something else, and some of it's actually developed. The facade also in Korea is an example of that specific facade was produced for that specific project, again, knowing the kind of economics and limitations of that one. So so sometimes it happens just trying something out, but again, if we can, we like to try to look at a couple of projects within an ongoing construction project itself.
Yeah, I imagine some of that research occurs through your relationship with the academy, right? I mean, you showed that triangle where you have practice, academic.
Yeah.
And how do you think it's changed your approach as your interest in this technology has developed? How has it changed your approach and how you teach and how you bring that?
Well, you know, when we teach, I think it's not about teaching something, but it's like working with guys like you and finding something else. So it's a question. So if the Gina, like the BMW guys, if you take technology out of the car industry and apply it to, say, suburban housing, which is kind of a crazy idea, but it becomes a question to find something out. So, so I suppose that's a kind of research aspect. We don't know where it's going to go necessarily. It's really coming back from the students. Another studio with the lightweight concrete we ran in Lucerne. So you kind of go into it with a series of material structural questions, and the student work is in a way the answer to that. So again, it's not so much teaching something as a technique, but offering a series of questions that through the studio, usually a semester, sometimes a year, respond to. And that's, that's what keeps it interesting for us also. We're not teaching to teach. We're teaching to find something out. Okay. Thanks. Nice to be here.